Hello. We're back with the stream thing. Uh, we're gonna do things a little bit different. It's nothing too crazy. We're just not working in. We're not gonna do a cat-like tutorial today. Today we're gonna try to make a pivot into AI. Hopefully. So I found this Learn Unity tutorial series that just goes over a lot of the individual aspects of AI and kind of breaks them down to the point where a lot of the first ones are a little too comprehensive. It's like about Cartesian planes and like coordinate systems and stuff that it's we get it by this point, but we'll still skim through just to make sure there's nothing like fundamental or misunderstanding. But then later on it gets to like stuff that we really need to understand in the context of game development better. Specifically for me, like dot product and cross product, I've looked it over so many times and I like it's not sunk in for me. So I'm hoping this will help having it taught in the context of AI. But then even further on, you get into stuff like pathfinding, giving the AI like crowd behavior, behavior trees, like all kinds of fun stuff like that. So, we'll build our way up, start with the basic stuff today, and work up from there. But first off, I do want to, just for the sake of the stream, just recap what I've worked on my own time off stream. So, well, first off, I worked on making it so my character blinks. So you can see she just got a little blink animation that just plays on top of the idle. So this was a good opportunity for me to learn about animation layers, which it's basically what it sounds like. You can have multiple like blend trees on top of each other. So you can see I have my base one here that's running constantly. But then on top of that, because otherwise it would be like a huge pain to get this to work. But basically I wanted the blink to just be constantly playing regardless of what state you're in. So you can see like while she's running, she blinks, and while she's jumping, she blinks and all that. And that's because the blink is independent of all of this stuff. It's on its own layer that is running just the blink animation. And then it just adds them together basically. And then I also have different facial expressions, as you can kind of see here. But we don't have enough gameplay to make like a real reason for that. So I just have these like emotion booths that you just walk into, and then it changes your expression. So she's a little happy. And each one has its own individual blink, because I found out that you have to... I just found out the hard way that I had to do that manually. Because I couldn't use the same blink for every single thing.
The whole texture has to change.
Yeah, basically. Because like you could see for this one, her eyebrows are up higher than they're supposed to. So when she would blink, her eyebrows would also go down for a couple frames. So it looked really fucking weird. But then like this one, I like this one a lot. This is kind of similar, but it's just like further shock. This is a really good example of it, because you could see like I have those lines and like the sweat drops and shit. It was the same thing. Whenever it played the blink animation, those would disappear for the blink and then come back. So now I have on top of having a facial expressions layer that does the base, just this is what the face looks like now. There's also a blink expression layer that also switches to different states. So you have your horror face and then your horror blink that it switches to. You got like... She's going like, huh? What? That kind of deal. Again, I mean, I was kind of just drawing the first expressions that came to my mind. I don't really know how these will be used.
Mm.
Pissed. The most evident one to me, like when I was first working on this shit, I was just thinking like when you take damage, she would kind of like wince, or maybe like when you jump, she would go like like make a little noise. So I'll probably make more gameplay contextual ones, I guess. But this was just the first pass of like learning this system. So basically, thank you. The way I did it was a little bit annoying, but it ended up working pretty well. I basically just have her face broken off of the rest of the mesh, and then I have the eyes and the mouth also two separate meshes, and they're just like parented the exact same way, so it doesn't matter at all. And I offset the UVs on the texture, so I had to make a new texture for just that part, which is just all the expressions she can have. Which is, I made it really big. Well, not really big, but 2048, which is double of what I've been doing. So I could just keep adding more and more and not have to worry about it.
Yeah.
And I worked with it within Sprite, so they're all on like an actual grid. So I can use math to just be like, like find the offset to be one to the right and then one down, and then just multiply it by the amount that I need to go over. That was also a mistake I learned the hard way, but it was a very good learning experience for sure. And yeah, you could also mix and match them. I can't really do it in Unity that effectively, but yeah, basically what it does is it has the UV is set to this face by default, and then I just tell it in code. I've made an animation in Unity that just says like for one frame move to this one, and it moves the UV over, and then I had to set it to be constant interpolation or whatever, because otherwise it would like scroll between her faces. She looked like a Lego head like spinning around. It looked kind of cool actually. It makes me want to make like a fake face character where you could see their face go like and like click between different states, but whatever. But yeah, that's really all I worked on. It took a lot of time, but it's not a ton to show, I think. It was just very tedious. But I did the event, what's it called? Fucking detection zone event-based system for all this too. So it's all a function in the animation state that I can just call and say like set her expression to this. So I could just do that anytime now. I could just say like when you jump, call this expression, or when you take damage, call this expression. It's just an event I can call now, which is pretty nice. Yeah. So now I don't think we're gonna be in Unity very much for this first bit. I think we're just gonna be kind of skimming through it because it's a very general thing. But once we get to the point where we get into Unity, hopefully, it'll be fine that we just keep using the same project file. But yeah, I think I'm good.
Cool.
Okay, actually I just kind of realized if it's a video, it's going to be kind of dumb that we're playing this independently. I forgot it was a video. I could change my Discord stream to be streaming Chrome.
That would be good.
And then you could just watch it through there. Okay, yeah.
I'm gonna go get some water.
Okay.
What should I put on my screen? That, I guess.
But yeah, I mean, I skimmed through the transcript a little bit too, and I think we could probably get away with just fully skipping this one, most likely. But it's 20 minutes of just explaining, like, what is a coordinate system, like X and Y and blah, 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 blah. So we'll see how much we actually end up liking this system. I wouldn't be surprised if we end up changing to a different thing. But yeah, you could see on the left here the amount of shit that we get to. The math of AI, the physics of AI, waypoints, the A-star algorithm, navigation meshes, finite state machines, autonomously moving agents, crowd sim, goal-driven behavior, and behavior trees. So there's a lot of fun stuff mixed in there. Especially the A-star algorithm. I took an AI course last semester and we went over this, so it'll be very cool to see it again in this video game perspective. And same thing, state machines. I use state machines in my robotics course, but also in just animation trees. Like, those are all state machines. So that's the kind of shit I'm excited for. Do you see the stream, though? Is that working?
Yeah.
And then you hear it?
Yep.
It's kind of loud. Oh, God. Not a strong opening. I thought this was like an official Unity thing. Who was holistic? Whatever.
Any debile.
I'm going to put it on 2x speed.
Euclidean geometry is a branch of mathematics that we use for the most part in games. It's a mathematical system first devised by the Greek Euclid and comprises the works
I think
of
she's already a pretty fast talker.
-1 x is -1 -2. The x coordinate must and always comes first, followed by the y.
Yeah.
We'll leave these details for later in the course and begin first by using a simple orthographic space to explore points. Now, as I've just said, in this project we're going to explore points in an orthographic setting. To do that in Unity, we're going to create a new project, which I've already done, but when you go to new project, you'll get this window pop open. Give your project a name, like points 2D, a location where you want it, and the template in this case you want to change to 2D. So it'll already be 3D, but set it to 2D. And then create this over in the scene. The scene by default when you create 2D will be set to 2D, which drag it up to the top of the screen, which would mean moving our y-axis. If we change our y in a positive direction, you'll see that the sphere goes up like that.
Okay.
Value is still on the origin. So this value here is going to be... Now, the sphere in this case is set to -1.72. Now, it doesn't matter what you set it to as long as it's in front of the camera. So our camera is at -10. So therefore, the sphere, if we put that at, say, -8, then we will still have it just inside of the scene. And we might need to go down a little bit for that sphere. So see the sphere here in our game view. In this type of orthographic projection, if I move that sphere back, the sphere, not the camera, select the sphere, let's move it back into the camera, and I'm moving it. The only time you'll see any change is when that sphere goes in front of the camera. So see that the Z value is not having
she
any
says
effect
Z too
whatsoever
on top
over the
of everything
movement
else.
of the game. This is what you want in 2D games, essentially. And the nice thing
I
about
feel
this
like
is that
I
you can
write.
add more
I
things.
write
and
Z.
so-
What? Like when you're writing Z, you think Z?
I put the line through it, and I think that's Z. That's different than Z.
Okay, that was like more basic than I expected. Oh, God.
Oh God.
No! Do I really have to sign it? Oh my God, hold on. Hopefully that it remembered the right
Just
thing.
mark is complete. You can continue without marking to... Oh, what? No, you can't. Wow.
Okay, I'm signed in now. Mark step is completed.
You can, if
Oh, I
you
got
click on it-
XP.
Oh, nice.
Oh, I'm gonna get all the XP. You don't get any of this shit. Oh my
Oh,
God. Too easy. Get out of my fucking face. Wait, start again? No, continue to next item. Wait, just went straight to vectors? Is that? Oh, okay, yeah.
Yeah.
Okay. I mean, we could also just skim the transcript first and foremost. See if it's even worth
I
our
don't
time.
even know if... I can't read this.
The way it's chunked up is weird.
Look very much the same as points. However, they are different.
Vectors themselves, when written as coordinates, look very much the same as points. However, they are different. The point 4, 5 is a single location 4 along the x-axis and 5 along the
Oh,
y.
it's not
from the
catching
origin.
up.
The vector 4
What do you mean?
It highlights the transcript. Or are you doing that?
No, it does. Is it out of sync?
Yeah, because you have it
Oh.
over 0.5.
4, 5, however, can start from anywhere in
Fuck.
space, but measure 4 in the x and 5 in the y.
Just ignore this part.
Whereas a point is a single
there we go.
location, a vector can be anywhere in space. A vector also represents a direction, the way it is pointing,
Hold on, wait,
and a
hold
magnitude
on.
held in the value of its length. This is very useful as it not only tells you which way it is going, but how far it is going. On a graph, the point 4, 5 is here. A vector that starts at the origin and also has a value of 4, 5 is an arrow drawn from the origin to the point of the same value. But we could also easily draw the vector 4, 5 here, here, and here. It's just a direction and magnitude in space. It doesn't specify where it starts. The magnitude of a vector is determined by Pythagoras' theorem using its x and y values. Do you think you can work out the length of this vector? Pause the video and give it a go.
Nah.
Recall Pythagoras' theorem where the length is equal to the square root of x squared plus y squared. In our previous examples, we've been finding the distance between two objects to do rotation 25. If we start at the point 7, 1 and travel along the same vector, we end up at 7, 1 plus 4, 5, which will give us our destination point of 11, 6. Again, a point is a specific location in space, whereas a vector represents instructions for moving from one location to the next. In the previous example, the vectors
To the transform vector. With that saved, go back.
Maybe I
That would be
should hear
completely
this.
different in the Z direction. That there. So to begin,
Yeah,
download
let's
starter
just
package
kick
for this
back.
lecture. In there you'll find a man character,
Just-
and on top of that has been added a move script. And it's the move script that we're going to be working in. So open that up and have a look in here. You can see in the script that there is a vector 3, which is a goal. So the vector 3 is the 3D version of our vector, which has an x, y, and a z. And we're initially setting that vector to be 5 in the x direction, 0 in the y direction, and 4 in the z direction. Because this is a humanoid character on a flat surface, when we move him around, we're not adding any y, because you don't want him to go up and float in the air. If it was an aeroplane or something that flies, that would be completely different. Notice also there's no physics whatsoever involved in this project. We're moving this character purely using our own code, and that's so that we can keep control of it. Now, in the start function, we're adding our vector 3 onto the current position of our character. So here we've got a transform, and we're running a translate. And basically what that does is it adds the goal vector to the transform vector. With that saved, go back to Unity and press play. And what you'll see is your character jump that much distance along that vector. Because it's in the start function, it's adding the whole lot at once and moving your character to that goal. Now, that's not going to work if you want to move the character bit by bit in the update and make it appear as though it's moving itself. So stop playing, let's go back into move and have a look at moving this translate down into the update. Get rid of the one from the start and save that, switch back into Unity and press play. And what you'll notice is the character completely disappears. But if you select the man in the hierarchy, have a look at the transform, and the position in the X and the Z are going up and up and up. And that's because that whole vector is being added each time an update occurs. And so he is moving, he's just jumping in very big leaps and getting further and further away so that we can't see him. So let's stop that. What we want, instead of jumping to the goal position, is to move in little tiny steps along here in exactly the same direction as that vector. So to get a smaller version of the vector, you can divide the larger vector by a number, and that will give you something littler. So if we just go back into move, and in here, with the update, let's go in the start, let's go goal equals goal multiplied by 0.5 f, and that's going to halve the size of the goal. So now he should move along the same direction, but you should see him stop halfway along and then jump to the goal location. But after that, he will keep cycling and adding the goal on. Save that, switch back to Unity, press play. Yep, you probably saw him jump a little bit there, and that was him moving in those, still a big leap, but only half of the vector each time. So let's go back into move. What happens if we multiply this by 0.01? So we get 10% of that vector instead. Anything you multiply or divide on the vector is going to still be in exactly the same direction that you want your character to go. So let's play this one, have a look. So that's much smoother in the movement, and he's moving towards the goal location. Now, the goal location itself wasn't a position in space. It was a goal direction. So there's a difference between a point and a vector. A point is a fixed spot somewhere in your world. A vector is just a set of instructions of which direction to move in from any location in your world. So your character is now somewhere, if you click on him, still moving along at 10% of goal each time. Now, if we simply multiply our vector, we want our character to move along by a small number, then whenever that vector changes, it's going to affect our character's speed. He won't be moving at a constant speed. And we can illustrate that by adding in another character. So first of all, let's make our vector goal public so that we can change it. Then we will still multiply it by 0.01 and translate along that. So just save that. Now, if we go back into Unity, get the man and just Control D to duplicate, and then move him out and try and put him sort of, we're moving in this direction. We want him to move parallel to each other. So I just want to put him there. But for this guy, his move goal, let's multiply it up by 2, so it's like twice as far away. It's like out here somewhere. And so let's make that 10, 0, and 8. Okay, so now when we run it, we'll see different speeds. See how this guy's going much faster? Because 10% of that longer vector is going to be a bigger jump than 10% of the shorter. So they're not at a uniform speed. And that's going to make the movement of your character inconsistent when they're moving along different sort of vectors and different length vectors. So the question is, how can we get a vector that is a standard size that points in the same direction along the vector that we're traveling along. And the solution is to get its normalized version. The normalized version of any vector is a vector that is 1 in length. And you can find the normalized version of a vector by dividing each of the x, y, and z values of the vector by the magnitude. Now you can also get Unity to do it for you. Let's go back into the move, and instead of having our goal here that we're moving along multiplied by 0.01 just to make it much smaller, we want to make it into a standard size. So let's just get rid of that altogether. And what we're going to do is translate along goal.normalized like that. And that will be a vector of unit length 1 going in the same direction. Now when you play, this will probably be too far. So if we just come back and run it, yep, you can see that they did move at the same rate, but it was quite jittery and it was a big hop each update. But we now know that we have a standardized unit 1 movement each update. And now that we have this, we can multiply this by a speed value to change how fast our character is going. So let's just create another public float and let's call it speed. And we'll set that, because we want to make it a bit slower, 0.1f. And then multiply your normalized goal by your speed, like that. And now because it's public, you could change the speed for each of those characters, but we'll just leave it at 0.1 for both of them because we want to see them moving at the same rate. Right, press play, and there you go. And they will go on forever and ever, because even though we gave them starting vectors that were completely different, they were pointing in the same direction, and then they got normalized down to a unit 1, and so they ended up with exactly the same vector multiplied by exactly the same speed. So it doesn't matter how long the vector is, if you normalize it, you end up with the same little vector, which is of unit 1. Now, those speeds, even though you think it's a consistent speed, the other factor involved in it...
It also seems like she's trying to make sure that like we understand the strength of normalization, you know?
An update, it's not
like even though they have completely different size vectors, because they're like the same direction, it doesn't matter.
Speed. And although you probably won't even notice these, you will see in a lot of code that people multiply by time.delta time. And what this does is it smooths out and allows for the difference in the update running. The other thing I should say too, before we finish up, is to make this a late update. Any movement you've got on your characters, and especially when you start to add cameras that follow things around, you'll want it all to happen after all the physics has been calculated in the scene. Currently we don't have physics, so it's not an issue, but you should get into the habit of putting your movements into the late updates, which I still am not, and feel free to correct me throughout if I do have an update loop with movement in it, because I'm bound to, because that's a bad habit of mine. So this should be all we need now to have a nice, smooth and consistent movement of our character. Save it. Let's go back into Unity and press play. And now, well, that speed's quite small, isn't it? And you can see that the multiplying of the time.delta time has also slowed it down a fair bit, because it's going to be quite a tiny value because of the time difference between update loops. And therefore that allows you to then play around with the speeds that you're setting on your characters. So maybe instead of 0.1, you might want to change these to 1 and try it out. Yeah, that's a bit better. But that really is the code you should use when you start moving a character around. Alright, so that's it for moving something in a straight line and how to get consistent speed in your character's movements. In the next lecture, we will start to look at moving towards a goal and making our characters turn.
Okay, okay. So the next one's going to be like creating a vector towards a point, I imagine?
This might relate to some of the problems you've had.
Oh, yeah? God, that's gonna be a problem. How hard it goes immediately.
This lecture extends on the last lecture by now moving our characters towards a goal where they will then stop. To do
Does
this,
that
you'll
goal
need
have
a
to
goal
be
location.
along a straight
I've created
line?
a simple cube by right-clicking 3D object and cube, and then positioning it somewhere in the environment. And we're going to get one of the characters to move towards the goal to begin with. So select the characters that are in the scene and make sure that you remove the script that's already attached to them. We're now going to create a new C# file called move to goal. It's a little bit different to the move code that we wrote before, but we still need to calculate with vectors. And at the top, begin by adding in a float for speed, and I've got that set to 1. In fact, I might just set that up to 2 so that thing goes a little bit faster this time. And then I have a public exposed transform called goal. Goal is now changing from the previous code. Before we had goal as a vector. Now it's a position in the environment. Now inside of our late update, we need to calculate direction. This is the vector between the goal position and the character's position. To do that, we simply minus where we're going, so the position of the goal, minus where we currently are. So this is where we're going, and this is where we are. It has to be in that order. If you switch them around the other way, your vector will be facing in the opposite direction, and your character will go along the same vector, or at least along the same kind of line towards your target, but it will be traveling in the opposite direction. If you ever get that happen, then you know that you've got these two things around the wrong way. Once you've calculated the new vector to travel along, you then again use your translate, and you put your vector you calculated inside, multiply by speed, and multiply by time.delta time. So we're still traveling along a vector, but this time we've calculated it. So save that, switch back into Unity. Now, you'll want to grab one of your characters and drag and drop that script from the project onto them. Here you can see I've got the move to goal script attached, and I have set the speed to 2, or the code did anyway. Grab hold of your cube and make sure you drag and drop that in as the goal position. Now, press play and have a look what happens. So your character has calculated the direction it needs to go, and it will get to the goal location, and then it kind of stops moving, but it's jittering. The reason why is because you're still inside that update loop, asking it to calculate the direction to the goal and move towards it. Now, in most cases, you're not going to get your character spot on the exact location of your goal, and therefore you need to have some kind of near enough is good enough calculation included. Just before we do that, I want to show you something. If we move our character over here now and press play, it will calculate a new vector to the goal and move towards the goal. Now, to stop that jittering that happens when they get to the goal, go back into the code, and we want to put something in the update here to test if we've reached our goal. And if we have reached our goal, then we don't want to keep calculating the vector towards it and moving towards it. So you can do that by testing the length of the direction. You've already calculated this vector, and can you remember what it's called, the length of a vector? It's the magnitude. So we can say if direction.magnitude is greater than, let's say, 5, just to try it out, then move towards the goal. So save that, and let's go and check it out. So
She doesn't
every
use
time a loop
brackets?
direction gets calculated, it gets
You don't
shorter and
have to.
shorter.
It's
The
just
vector
You don't have to
itself
do
doesn't
brackets?
stay set to the original
If it's
vector.
just one line
Even though it's
after
still in the
if,
same direction.
I didn't
and
know
there's nothing
that.
else behind it,
Shorter.
then no.
So now you can see that it moved. What happened didn't move very far, and that's because a distance of 5 is about that distance in this case, because these are quite small little characters, and you'll have to take it upon yourself to check the scaling that's going on within your world. So let's go back here and let's make this, let's try 1 and run it again. Okay, so that must be a distance of 1 from the cube. And if we click on the cube and have a look at the one I created, you can see that the scale is 0.2. So that makes that cube in world terms about 20 centimeters across. When a cube is at size 1, which is its default size, that would be a meter by meter by meter in the Unity world. And therefore, you can imagine that 5 of those cubes would have fit across that space there for that distance of 5 from before. Now you can see that 1 is still quite large if you want your character to be right on top of the goal location. So let's just try once more with a smaller value. Go back into move to goal, and we'll change this to 0.2f. Save that, and run it again. And the character should be very close to the target in this case. And you can see that he is, so that's pretty acceptable. I'm going to move this value of 0.1 up the top. So let's make this public float, and let's call it accuracy, because it is the accuracy that we're willing to take as far as being close to a goal. And let's set it to 0.01f. So we're going to make it very close, and then down in here we'll put accuracy, like that. All right, so save that, and we'll switch back and run it, and just see if that makes any difference with that very tight accuracy. No, that's pretty good. What I want to show you is something that will cause your character to still jitter with this particular code. Let's change the speed to 5 with that really tight accuracy, and let's run it again. Okay, so the character jittered before it eventually got within that accuracy. And what's going on here is that it got to the goal, it overshot the mark, it recalculates the direction back towards the goal, overshoots the mark, and ends up bouncing around like this. Because your 5 accuracy here is pushing it over the goal and then pushing it back over the goal and pushing it over the goal like that as well. In this case, we were lucky where it did eventually move to a position that it could get within that accuracy, but sometimes you won't get in with that accuracy, and you'll get some really strange behavior going on as far as the character dancing around the goal spot. And that's because it never ever is getting there within your accuracy. So if you get that, just play around with your accuracy values until you've lifted them up high enough to stop that from happening. Otherwise, you're going to have to reduce the speed at which they are attacking your goal position from. I'm going to put this accuracy back up to 1.
Do you think using a volume would be
Other
cleaner for
character,
that?
Let's put the same code onto it and leave it with the default speed, but let's
Like
say
having a
press
volume that's just like once you
0.1 instead
go
of
into the
1.
volume,
And we also need to
they
set the
call
cube
a function that
into
just
the goal
stops
location for this guy
the
here.
navigation
and now if
or
we press
whatever.
play, they'll move towards the goal position. As we've currently
I
got
don't
it
know, I
working,
don't-
they will slide along from their current position to the
think
goal position.
so.
They don't turn and face the direction that they're traveling in.
feel like
and that
that-
would be a nice addition.
The way
for a
she wrote
character to
it's
do
really
that.
smart.
Now,
Where
Yeah.
it
before, or
cancels.
should I say, in the olden days, we
cancels
had to
after the
calculate
if isn't
angles between
true.
vectors and which side the vectors were
I
on.
feel
relative
like
to
when
other
I-
vectors in order to figure out how to
I
turn your
was
character
thinking of it
around.
in my head, and I
Now,
wrote it
we've got this
the
great
opposite
function
way.
called lookup
And
that Unity
this is
has that does
better
all
because
that
it
hard
automatically
work for
turns
us. And
off
I'm going to put it in the start function so that our character first turns
once it's not
and
true.
looks at where it's about to go. And that method or function
Or
is
rather,
called look at.
no, yeah.
And you add it to the end of the
It's
transform,
not that it's
and
turning
then
off,
give
it's
it
just
the
like
goal
by
position
default
that you want
off,
your character to look
and
at,
then it
and
only
will
turns
snap
it on
around
when
and look in that direction.
it's like
Now,
out
at this
of
point,
range.
if I run it, because we've changed the orientation of the character,
This is kind of what
this
I was talking
translate
about with
is
the
not going to work properly. And
the
we'll
whole
just
thing where
save
like
this
a
and go back and
character
have a quick
follows
look
a
at what you get, and I'll show you
goal
how to fix it.
around.
So there
Goal
we
is
get
the
this. And
best
you can
word
see
for
that
it, but
the characters tend to arc
the GTA
towards
thing.
it, and this character is going
Hmm.
to just sort of spiral around and get until it gets close enough. What's happening there is that now
Like
that
if
these
you just
characters
control the
are no
goal,
longer 000
Yeah.
rotation up
or
here.
if
Like
you
a
have this
Pikmin.
script,
Mine was 000 rotation.
yeah,
If you've
like
been
if you
following
had
along
this
and you
script
change
on
the
an
rotation
object
of your
and then
characters,
you
you
put
probably
the
couldn't
ball
figure
as
out
the
what was going on
goal,
with your code, and this is the exact
and then
problem.
made the ball
So
invisible,
in your move to
it
world,
would
what
look
you want
like
to
you're
do in your
controlling the character.
translate is you want to
If the
translate your
character's
character
like
along
close
this
enough
vector
the whole
in world
time.
space, as opposed to local space. Now, if you save that and run, you'll see that your characters turn towards their goal, and then they travel towards it. Over in the scene, I've got these red lines that you would have seen, and that's drawing in the vectors from the code with a debug.drawRay, which draws a ray from the position in a particular direction, and then you give it a color. This is really useful for debugging to see what's going on. So I've just included that so that you can use it in your own code to see which vectors
I gotta
are going what and
remember
which way
that.
they're pointing. All right, so that's the easy way to do a look at.
Yeah, we didn't
You might have
take
noticed
in the
at this point, if we run it
gizmos
again,
and debug
and you
stuff.
grab hold of the cube, and in the scene you move it around, you will get the characters responding to its location just naturally because of what's in that update. Notice though the look at isn't updating, and that's because it's still in the start function. So if we change that look at here and make sure that we recalculate it every time within our update, the characters will always be looking at that cube. And then what you could do is get some driving script so that you can drive that cube around with the arrow
There it
keys,
is.
and the characters would move wherever it goes.
Very nice.
Big Sibby mentioned me.
And he added you in something? What?
He wants to play Jackbox.
Where did he... Oh, he just messaged you?
In the big chat.
Oh, I don't have my phone. Okay.
Yeah.
I mean, I guess I'm down, but we just got a little bit longer to go here.
Yeah. After.
Yeah, I think we're good on vectors here. But yeah, I've tried using... I think... I don't remember if it was look at, but I did something similar to that for one of my fixes on getting rid of the velocity check thing.
Mm-hmm.
But I think there's a different problem. I think there's a bigger, like, fundamental problem.
Yeah.
Just because, like, even when I do the one straight by the book, it's just like the most basic thing, face your input. She just, like, face plants into the ground and spins around. Like,
Mm-hmm.
there's something else going on. Okay. Distance. So I think I don't know, we're almost on dot product. But yeah, we could just run through mathematics of AI probably right now. Complete that whole
Yeah.
chunk.
It's a chill stream.
Recall for
Yeah.
a moment, if you will. Going to need 2 points. Normalizing vector between 2 games.
I'm just trying to skip the intro. Okay.
A commonly used calculation in AI is working out the distance between 2 game objects. It's not only important in
Oi, oi.
determining where things are in the environment with respect to one another, but also for calculating angles and normalizing vectors. You'll see the distance calculation used over and over again in this course, especially when trying to determine if an enemy is
Oh.
in range.
I was going to bring this up too. I don't know if it was in this one. I don't think it was in this one. But one of them said it was a part of the course was making a tank enemy that calculates the trajectory of how to hit its target. And I immediately
nice.
I was like, pull time. Like, that's...
Yeah.
So we should... I think I sent it in the Discord, so maybe that's another thing we could get to. I don't think it was this course, though.
I was thinking of how to do that today. Like, I feel like I need to just do it.
I feel like we're definitely closer now than we've ever been to being able to make that. So
Well,
Yeah.
do you remember how I was gonna make that I was working on that first person thing for a little bit.
Oh, yeah.
Um, I did that because I thought like I want to try and make a really simple shotgun like effect, I
Okay.
guess, just to see if I could do it. Because I was thinking like I don't know what it is. Maybe it's I want to say maybe Overwatch is the one that has this where the like Torbjorn's shotgun is like they're like physics objects.
Oh, yeah, it's like a glob.
Yeah. So that was something that I wanted to try. Was like physics objects based shotgun blast.
Are you sure that they were actually like physics objects? It wasn't just like a projectile system?
I mean, yeah, I guess it was a projectile system that had just drop.
Oh, I see.
It had drop and spread,
Okay.
which is like those are two things I don't see very often, I guess, combined.
Yeah, especially in a
That's-
shotgun.
Yeah.
A shotgun, you immediately think of just like rays coming out of the tip of it.
Yeah. But if it was
Um,
like a somewhat physically accurate, that was the thing I was
That
thinking
could
of
be
doing.
fun.
And then I was thinking of doing that and combining it with that idea of like reflective projectiles. Like Destiny has that also, where some weapons have like ricochet rounds that shoot off the wall.
Well, that's funny because I was thinking about pull time today as well. Because I was thinking of if there was like, what if we could do like a light version of pull time within Mall King? Like if we just had like a pool store and just had like just I don't know if it would be straight up full time guy or just some way to like on a micro level get just that mechanic working and then just throw it into Mall King. It's just like a fun little thing, and then later
Yeah.
it's like, oh, it's a whole game now, you know. that kind of idea.
That game idea is like 100% reliant on having one good boss AI with like a
Yeah.
lot of branches for a lot of different behavior. So like if we can get good at AI, then I feel like we could probably jam that out quickly. It's a pretty small idea.
Yeah. Okay, that sounds good. But yeah, I just thought that if we had it in Mall King as an idea, that would be like a good short term goal, you know, of like practicing it. But it might be better to just have the short term goal be just make it. Yeah.
I mean, yeah, instead of trying to make it a big thing,
Yeah.
instead of trying to make a small project big.
Okay. Well, let's move on.
Or where other resources are. To calculate a distance, you're going to need 2 points. These can be 2 separate locations or either end of a vector. In this case on the screen, I've got the tank that's at 3 on the X and 2 on the Y, and the fuel cell that is at 12 on the X and 10 on the Y. So how do we find the distance between these? Well, any 2 points in an environment, whether it be 2D or 3D, can be used to form a right-angled triangle, as you can see here. Once you have a right-angled triangle, or that you know that it's
Isn't
possible
this
to
a
form
built-in
a
method?
right-angled triangle, which it always is in this case, then you can
What,
apply
make a
Pythagoras'
triangle?
theorem.
Well, can't
now,
you
do
just
you
say
remember
like
what
dot
Pythagoras'
distance
theorem
or something?
was from your high school
Or like
mathematics?
distance and then call
Well,
the
recall
two
for a moment, if you will,
points.
the longest side of a
think
right
she's
angled
gonna
triangle
go
is
over
called
that
the
with dot
hypotenuse.
product.
And the other sides, if we label them A and B, and it doesn't matter which order you do that in, then Pythagoras' theorem says that the length of the
Wait, what?
hypotenuse equals the square root of A squared
Should I
plus B
pause?
squared. So that's the
Command?
lengths
Yeah.
of
What
A.
is the command you're talking about?
Well, I was saying like so say like the tank is point A and the fuel tank is point B. I thought you could just say like vector 3 distance AB and then it would just give you a vector that is the distance between those two.
Yeah.
So I mean I'm assuming if that's a thing she'll mention it,
Yeah.
but I guess she's going to go through the like nitty-gritty thing first and then she'll be like
Yeah,
you
I
can
think-
also do it automatically.
Yeah, I think she's just explaining what it does.
Okay. But you think that's a thing too though?
Yeah, I'm pretty sure you can just get the distance between. But you could also get the magnitude of the, like, subtract the two positions and get the magnitude. There's like a bunch of ways to do it.
That's true. Yeah, I feel like we've done this before where we like calculated the distance between two things, and I've never had to like write out the Pythagorean theorem like in code.
Yeah.
But I mean, I guess maybe we did, and I just copy and pasted it. Whatever.
A and B squared. And how do we find these lengths? Well, if you have a look at A, it happens to be the difference in the x direction
Yeah.
of where the tank is and where the fuel cell is. And B is the difference between where the tank is and the fuel cell is in the y direction. So what does this look like when we work it out? Well, first of all, we need to figure out what A is. And A is going to be the difference between the x coordinates of the tank and the fuel. So x1 minus x2. And B is going to be the difference between the y coordinates of the tank and the fuel. Now, we're going to do a squared operation on these. So it doesn't matter what order you do them in, as long as if the tank is item 1, then the fuel always remains item 2. So that the x and y coordinates have to be in the same order inside those equations. So then when we plug in the actual values, we get 3 minus 12 squared plus 2 minus 10 squared, which gives us down the track 81 plus 64. The square root of that is 12. So that means that the length of the hypotenuse, or the distance between the tank and the fuel in this case, is 12.04. Now, it doesn't matter where in the environment your points are. You can always make a right-angled triangle. But the important thing here is that that right-angled triangle is going to have one side that is parallel to the x-axis and one side that is parallel to the y-axis. And the length of those two sides are always going to give you that difference that you need to put into Pythagoras' theorem. So let's put this into practice. What I'd like you to do is open up a new Unity project and bring in the starter package for this lecture. You'll find when you get in there a scene called Tank Starter. Open that one up, and in there you'll see a tank and a fuel can, and this is in 2D. And if your scene is a little bit around the wrong way, okay, you might not be able to see anything, you need to be actually looking down the z-axis in the negative direction towards the blue axis there, and then you can just sort of flip that around a little bit. It doesn't really matter that you can't see it in there because we're going to do everything in the game view anyway. Now, the tank has a drive script on it. If you press play, you'll be able to use your arrow keys to turn and drive the tank around. So what we're going to do in this lecture is to actually calculate the distance between the tank and the fuel can. And we'll do that inside of the drive script. So let's open that up. Right, so here's the drive script, and it's just taken off of the Unity documentation on the website. If you were to do a search in the script section for get access, you'll find this really simple drive code. And all it does is it drives the translation and rotation of any object that you put it on using the vertical and horizontal axes, which are your up and down arrow keys and the side to side arrow keys, as well as the WASD keys that you're probably familiar with from gaming. Right, so what we're going to do is to work out the distance, and we'll actually do that in a separate method.
From
and we'll call that method when we hit the space bar. So down inside of update, let's come down here and we'll put if input dot get key down is the key code dot space. Then what we're going to do is run a method, and we'll call this calculate distance. All it's going to do is just use a debug log to print out the distance. Okay, so that's all you need in update. Let's go up above update where we will put this method in. So it's void calculate distance. And in order to calculate the distance, we need to know about the fuel tank. Okay, so this is going to go on the tank, and we need to pass in the position of the fuel. So at the top here, I'm just going to put through a public game object for our fuel. Okay, so with that, just save it. Flip back into Unity, then over in the hierarchy, if we click on the tank, you will see the drive script that's attached down here. You want to get your fuel can, drag and drop that into the position of the fuel. Okay, so let's go back into our code, and in here you now have access to both of the points that you need to calculate the distance. You've got the fuel, and you've also got the tank. The tank is what this is attached to. So what we're going to do is calculate the distance using Pythagoras' theorem, which is equivalent to the square root of the difference between the x and the y values squared added together. The calculation is on the screen at the moment for you if what I said didn't make sense. Now, I'm going to leave you for a moment and pose this as a challenge. Can you write the code that you would put in here to work out the distance? So let's just start with a little bit of code. First of all, you need to...
Can you do it?
Points, don't you? We need
Vector
vector
3
3,
dot distance.
which will be our tank position. And that's
What is
going
the
to
fucking
equal
command?
this
It's a cheat
dot
code.
transform dot position. And then we're going to need a vector 3,
Well, that
which
wouldn't work
is
here.
the fuel position. So fuel
You
position
need to get this
And it's gonna
dot
equal the
transform
fuel.
dot position.
dot transform dot position. Okay, so they're the two values.
I could just
that
put those as
include
the arguments,
x and the
though.
y value that you would use in Pythagoras for two
Yeah,
dimensions. Now,
I
what I
guess
want you to do
that's
is
true.
calculate the distance. So it'll be a float distance, and that's going to equal the equation that you're about to put in. And then underneath that, we're going to put a debug.log of that distance. So let's just put distance plus distance.
Transform
Okay, so
dot
pause the video
distance, is
now
that it?
and go ahead and write this formula here. I want it to be in the form
Maybe.
of
I
the
don't know.
Pythagoras theorem. Okay, so don't use any cheaty Unity methods that you
Oh.
already know about. It's got to use the values out of here, and it
Yeah.
actually does have to use square root and the power methods from the math class.
Not real
Okay,
math.
so
it's
good luck with
just
that.
Unity.
When we come back, I'll go through the solution for you. So how did you go? Did you get some kind of calculation out, and does it make sense what the distance is? Because sometimes you'll create
I mean, as
an
we get on
equation
in these
and-
videos, I would like to actually pause and do shit like that when she asks us to, but I don't think we need to do that, right?
No.
and calculate something, print it out, but you're not quite sure whether it's right or not. Let's go through the steps. First of all, let's write our equation out. First, I'm going to get rid of this long name that I've used for tank position and put it as TP, just to make this a little bit more readable when we type in the equation, and FP for the fuel. So what we need is a mathf.square root, and inside of that square root, let's put that on the next line, we're going to have a mathf.power, and that's the power. And what is going to be to the power of 2? Well, it's going to be the TPX value minus the FPX value. So inside of here, we'll put the TP.x minus the FP.x, and we will raise it to the power of 2. Then we're going to add to that the same thing again, but the y value. So mathf.pow of FP.y, of TP.y minus FP.y, comma, 2 to the power of 2, and then we need to actually end our square root. So you should have something that looks like that. Now, you might be wondering, do you put the TP first or the FP first? Okay, which one's X1, which one's X2? Well, it doesn't matter, as long as the order that you've put them in here is the same as the order that you put them in here. So if you're going to use TP as point number 1, then you have to make sure that it's point number 1 over here. Okay, so just keep those in order. So how did you go with that? So let's just realign my code here, and
How did you
I'm going
go
to
with
just
that?
save that, and we'll flip back into Unity, and we will try it out. So this is going to come up on the console. So let's press play, and we will just drive our tank around and hit the spacebar, and a distance has come up of 43.83. Well, is that correct? Well, it's a bit hard to tell, isn't it? If we got really close to the fuel, you would imagine that that would go down. So if we're practically on top of it and we hit the spacebar, we get a distance of 1. Okay, so it's possibly working. We can be absolutely sure, though, that if we stop playing and go back into our code, then we can actually find out what Unity thinks the distance is with the Unity distance function, which is most useful because you don't have to write this out every time you're doing a calculation, but it's always good to know how that calculation is being done. So let's create another float, and we'll call this the Unity distance, and we will put equals, and for this it's going to be vector3.distance. And that's a method that takes 2 vector values, and that's TP and FP, like that. Much easier than having to write out Pythagoras, but Pythagoras is a really important equation that you should really know off by heart, because you never know when you might need it, and there's no distance method around. Okay, so we now have that Unity distance. Let's do another debug.log, and we'll print that out. So we'll call it the Unity distance, and plus the Unity distance on the end there. Okay, so let me just put a space, it's a bit more readable for you. I'll save that, and let's go back to Unity. We'll press play, and then we're going to just hit the space bar straight away and have a look at the values that we're getting. Okay, so down here in the console, our distance that we've calculated with Pythagoras is 53.55036. Okay, Unity's distance is 53.58769. Now, it's not exactly the same, but it should be exactly the same because Unity's distance function uses exactly the same calculations. So what have we done wrong? We're going to assume that the Unity distance method is correct, which it is. We've obviously done something wrong. It's slightly out. Do you know what that is? Well, let's take a look at the transform positions of the tank and the fuel. So if we click on the fuel, it is positioned at
Who are
X
these guys?
23.5, Y is 9.8-ish,
guys.
and Z is minus 2.
It didn't
Unless you move it, of
come
course,
up
and then
for
it'll be
you,
somewhere
or
else. And the
Wait.
tank,
What happened? What do you mean?
The guy on the question mark. There was a guy with.
Oh, yeah, the guy. Yeah. That guy. I think that's
I feel
like...
like I just let it slide the first couple times.
we click on that and have a look.
Can we
You can
roll
see it
back?
obviously
roll back the
3.5,
tape.
Y is 9.8.
I've just realized that I
if we
looked
click
at the
on
first
the
one and
fuel,
it did not
it is
even
positioned
register.
at X
I
23.5,
was just
Y
like,
is
that is a question.
9.8-ish, and Z is minus 2.
Just question guys.
Unless you move it, of course, and then it will be somewhere else. And the tank, where you click on that and have a look, you can see it obviously at a different position in X and Y. So this is the Y axis going up the screen, and the X axis is going across the screen. And you can tell if you look at the little gizmo up in the corner here, this little gimbal thing, that you've got your Y going up and your X going that way. That means that Z's coming in and out of the screen. The Z value for the tank is 0, and the Z value for the fuel is minus 2. So there's actually a difference there with those two objects. And when Unity does its
How are
distance
we supposed
calculations,
to
it does
guess
it with
that? What the
three-dimensional objects. So even though we are working in 2D, there's still a Z factor involved in the calculation. So what we're going to do is actually change our own calculation. Back in our code, we've got our distance calculation down here, and you can see that we're calculating it using the x and the y. If you want to include z in here, so a third dimension, then we simply just add another set of values on. So we take a copy of this, and I'm just going to put that on the end here, and we include the z-axis in there. So it now becomes the square root of the power to 2 of the difference between the x's plus the difference between the y's plus the difference between the z's. All right, so save that, and let's switch back into Unity. We'll press play and hit the spacebar. Okay, now let's have a look at our calculations, and in this case 53.58769 and 53.58769. So we're now actually...
Okay, well, that's the end of that one.
Yeah. Not much to that one.
Yeah, that one was kind of bullshit that she was like, oh, can you figure out what the difference is? And it's like, I offset them on the Z even though it's a 2D thing. Like, how am I supposed to guess that? Fuck you. You lied to me and told me it was 2D.
I mean, in a way, it was expected, because it was just called calculating
There are
distance.
two powerful
I
mathematical
feel like
tools that we can use with numerous vectors to give us a lot of extra information.
I don't even
about
know
how
if
they
Cat
lie in
like
space
could
and
write
fit to
something
one another.
called calculating distance and make it that complicated.
simple.
Like, yeah, I mean, like at a certain point, it's
They are the
pretty
dot product
easy.
and the cross product. In this lecture, we will be examining the dot product and how it can be used to turn a character towards a goal location. The dot product is the sum of the multiplication of the corresponding components or coordinate values in two vectors. Given the vectors v and w shown here, the dot product is found by multiplying both x values together, both y values together, and then adding the result. It is written as an equation like this, with a single dot between the vector names. This is not a full stop, but an actual dot that sits above the line. The full equation then appears thus: v.x multiplied by w.x plus v.y multiplied by w.y. So taking the values from the vectors we have in this case, the equation becomes 3 times 6 plus 3 times -1. The dot product in this case is 15. Have a go for yourself. What's the dot product of these two vectors, 0, 3 and -4, 2? The equation becomes 0 multiplied by -4, which are the x coordinates, plus 3 multiplied by 2, which are the y coordinates. This results in a final value of the dot product for these two vectors being 6. Now you're probably sitting there thinking, so what? What does this value we are calculating mean? Well, it tells us a few things about the relative orientations of the vectors. Bear with me for a moment and work out the dot products for each of these pairs. Pause the video while you do it. Write them down.
I mean,
Were you paying attention?
I don't think
I wasn't.
I mean, I guess I'll do it. So it was, what the dot product was v dot w, which
Just
is,
go back a little bit.
you mean rewind?
Yeah.
Okay. Do you want to just watch it back? Or do you just want to see that?
Just that.
So it's v dot x times w dot x plus v dot y times w dot y. Okay, do you have that done?
Yeah.
So now we're on to this one. So I guess this is v and this is w.
Did in my head. So maybe it's wrong.
I'm
but
still
pretty
on.
Sure.
I'm on C, but I'm almost
Okay.
there. Okay, I have my answers.
You just press play.
How did you go? The dot product for A is 10, the dot
Yes.
product for B is 0, and the dot product for C is -7.
Let's
Now,
go!
Have a look at each of the values that you've got for the dot products and how the pairs of vectors are orientated with respect to one another. Can you notice anything? Well, in the case of A, the dot product is a positive value, and the angle between the vectors is less than 90 degrees.
I think cross product
Then
is the
B-
one that is harder to do in your head.
Yeah. From what my research, I remember dot product being seen as kind of the easy one,
Yeah.
but I still didn't get it. I mean, I understand how to calculate it now, but I still don't get what it means, like, when what I'm trying to get by doing this, I guess. And I'm hoping this will answer that question.
the vectors are at 90 degrees to each other, and the dot product is 0.
This is what
For
we've been
C,
working
the vectors
towards.
make a greater than 90 degrees angle, and the dot
Understanding
product is
a
less
dot
than 0.
product.
So just to recap, if the dot
What?
This is what we've been working towards.
Yeah. This is such a step down from Cat Lake. Like we've been building up so much with Cat Lake, and then just like a step back for sure. But I need this.
I do too. That's what I'm serious. It was proven this is something that is missing.
Yeah.
We didn't get it through all of Cat Lake.
product is greater than 0, then the angle between
I actually think I'm going to roll that back. I want to hear that again.
B, the vector
I don't know what
Can you
point
notice
she's
anything?
making about.
each of the values that you've got for the dot product and how the pairs of vectors are orientated with respect to one another. Can you notice anything? Well, in the case of A, the dot product is a positive value, and the angle between the vectors is less than 90 degrees. In B, the vectors are at 90 degrees to each other, and the dot product is 0. For C, the vectors make a greater than 90 degrees angle, and the dot product is less than 0. So just to recap, if the dot product is greater than 0, then the angle between the vectors is less than 90 degrees. If the dot product is equal to 0, then the angle is exactly 90 degrees, and if the dot product is less than 0, then the angle must be greater than 90 degrees. Where is this useful in games? Well, it allows us to determine whether one game object is in relation to another game object. Let's say we have a tank and the fuel. The vector showing the forward direction of the tank is the direction that the tank is basically looking in. If you draw another vector to the fuel from the tank, you can then use the dot product to determine if the fuel is in front or behind the tank. And this very same principle can be used if you have, for example, an automatic weapon, or you have some kind of camera that wants to detect whether the character has walked into a certain space. In this case, if the fuel is in sight of the tank, the dot product of these vectors will be greater than 0. However, if the fuel is behind the tank, then the dot product will be less than 0. We will revisit these principles later on, but for now what we're most interested in is turning the tank to face the fuel before it moves towards it. So the first problem we are faced with is to find the actual angle between the forward-facing direction of the tank and the direction to the fuel. The relationship between the dot product and the angle between the vectors can be expressed like this, where the derivation of this formula is taken from trigonometry and included in the article attached to this lecture. This can be further rearranged to make the angle the focus of the equation so that you can write a method that will return the angle between the vectors. And in this case, it works out to be the inverse cosine of the dot product of the vectors divided by their length multiplied. Now, if all of this math looks a little bit too complicated and abstract for you, don't worry, we're going to go through an exercise and we will take it step by step. So in order to find the angle that our tank needs to turn towards the fuel, first of all, we need our two vectors. We need the one that indicates the direction in which the tank is facing, and we need the one between the tank and the fuel. Now, to find the one in which the tank is facing is pretty easy because in Unity, it stores it within the tank itself. And that particular vector is, in this case, the up vector on our tank. If you were in a 3D environment, which we will be a little later on when we're looking at this type of angle turning in our AI characters, then the forward direction that the character is facing is actually along the Z axis. So you just have to be careful about which one of those Unity transform axes you get hold of to use. Okay, so this time we're using the up. Now, in order to find the vector between the tank and the fuel, we actually take the fuel's position and we minus the tank's position. The result is a vector, and it's the vector from the tank to the fuel. Okay, so let's start implementing some of this, and we'll do it again inside of our drive script where we're calculating the distance. Down in the update for our spacebar, we'll also add in calculate angle. And we'll do the same thing that we did with the distance. Let's just go back up here, void calculate angle. And we're just going to calculate the angle and then print it out. So let me get you started before I leave you for a moment to see if you can give it a good go yourself. So vector 3, we want our TF, which is our tank forward vector, and that's going to be this dot transform dot up, because as I said, in this case, the forward vector is the Z axis. And then we need the vector to the fuel position, so I'm going to call that fuel direction. Okay, so we can also have a vector that is pointing in the direction you're facing, but you can also have a vector that actually spans the distance, and the vector is actually pointing in the direction to go to that particular thing from one position to another. So the fuel direction in this case is going to be the fuel's position. So that's stored in the fuel dot transform dot position, and then minus this dot transform dot position. And there we have our two vectors. All right, now, when you're actually doing these kinds of things and working out your calculations with vectors or even points, it's really good to give yourself some kind of visual feedback as to if you're working with the right things. Often you'll type a lot of code in and then something's not working and you'll like go, what on earth is this not doing, or why is it doing this? You need to examine every single value. Now in this case, we need to know for sure that both of these vectors we've got, that one is the forward direction of the tank and the other is the direction between the tank and the fuel. And so what better way than to actually draw them? So I'm going to put a debug.drawArray in here. I use these all of the time to visualize what I'm actually trying to work out, and you'd be surprised how often you end up with the ray or your vector in completely the wrong place than what you actually think that you're doing. So
That might actually be, if I put that on my character and then put it to like, well, I guess if I tie it to velocity, then it would just show me it pointing in random directions like the character already does. But like, maybe I could find some other, I feel like that sounds very useful.
Yeah, I think maybe you have to sorry. You might have to figure out a different way to get transform up than just this transform up.
Yeah, but we already have that. I think forward is the problem, not up.
Yeah.
So we need, yeah. So same thing.
So to draw a ray, you have to give it the starting position. Now in this case with the tank, it'll be this dot transform dot position, and then we give it the direction of our ray. And the direction of the ray is actually the vector. So in this case, we'll just give it TF. Okay, now we can put some other things in this draw ray, like color. We'll make the color dot green. Make sure that's a capital. It doesn't want to make it a small case. And then we also want to give a duration of how long it's going to stay on the screen. So let's say 2 seconds, because this is going to happen after we hit the space bar. Now we want to do this again with our other ray. So debug.drawArray.
Right.
And this time it will again start at the position of the tank. So this dot transform dot position.
I don't know about big
and we want it to
case.
go off in the direction. So we want the fuel's direction to be our vector. And let's do color.red for 2 seconds as well. Make sure that's a capital. Okay, so currently we're not doing any calculations, so we're just going to draw these rays to make sure we've got the right one. So let's just save that, switch back into Unity, press play, and once you can drive around, press the space bar, and you will get your vectors come up on the screen. And you can see the red one, it stays there for 2 seconds, which is definitely the vector between the tank and the fuel. There's also a green one, which is really, really tiny. It's just in there. Okay, so by default, your vectors that belong on your game object, so your transform.up and your transform.forward, they're of length 1. And so you can see it's actually quite a very small length, and they're actually already normalized. If you want to see that a little bit bigger, let's just stop playing and we'll go back into Drive here. What you can do is just multiply the size of these vectors in here so that they're just a little bit bigger. Now, FD was big enough, okay? We could see that because it went directly between these 2 points. It hasn't been normalized. Okay, save that, back into Unity. Let's just press play. And now if I hit spacebar, you can see that we've now got this forward vector a little bit longer so we can actually see it. Now, if I move my tank around and hit that again, we should get our vectors calculated to the new positions. Okay, so we know now that we have the right vectors to do our angle calculation with. So now it's back into the code. The formula for the dot product and also for working out the angle is now on the screen. What you need to do is, first of all, don't panic, but just work through each of the symbols one by one to get them to work. So you know how to create your dot product is to multiply the x values with the x values, the y values with the y values, and add them together. And then you have to use the inverse cosine function in order to do your calculation, which also includes the length. Now, the length of a vector you can find using Pythagoras' theorem, because a vector is basically a line going between 2 points. And that will give you your vector if you have your starting position and then you know what your ending position is. Just to make it a little bit easier for you, Unity has its very own method built into all vectors, or property I should say, that will give you the automatic length. So if you wanted to find out the length of, let's say, this up vector, now we know it's 1 because I just told you it was 1, but TF dot magnitude is the length of a vector. Okay, so we also call the length of a vector the magnitude. So FD dot magnitude will give you that length. Okay, one last thing I will tell you before you go away and try and work on this is that if you want the inverse cosine, it's math f dot acos. Okay, so that's going to be the surrounding method of the calculation that you're going to put in between here, as I'm showing on the screen. Okay, so pause the video now and
Yeah, this one
give that a
doesn't
go,
really feel
filling out
like
what's
a
going to go in here, and
like
then
a
put a
math
debug.log in
challenge,
for
just-
the answer
just
to
like-
print out the angle that you
like,
have
can you
calculated.
write this out? Like,
Welcome
I
back.
don't know.
How did
I
you
don't
go
think we need
with
to do
that
that.
challenge? If you're not used to maths in this symbolic way, it can get a little bit difficult to try and figure out what you're doing. But that's okay, because Unity is going to give us a fantastic solution that I'll show you in a moment. But I really like you to appreciate what's going on underneath. Okay, so let's write this out kind of longhand. First of all, let's do the dot product. So that's going to give us a float value, and let's call it dot, and that will
Actually, do you
equal-
want to just skip to the part where she uses the dot product built-in thing, or
Yeah.
as I put out
I was gonna say we could probably just
Put that-
skip to cross product.
angle, and then we can go, is going to be in radians. Okay, so if you have a look, right, so we're going to plus, and in, let's just save that, switch bar, we've got
oh wait, she did it here already,
Rules
I
and we-
think.
our vectors, and now vectors are T, F, and F,
I can't see it.
D.
Where's Unity angle?
Okay,
Oh, I
so
guess it's
there you
probably
go, now we've got
down
both of them,
here.
let's just,
Where is that? Oh, vector 3 dot angle.
save that, switch back to in the console,
Oh yeah.
32.5934, which is the one we calculated, and Unity's is 32.5934 as well. Now, if we bring up those two vectors again a few times, you can see that this little angle here, have a look at it, is about, well, it is, it's exactly 32 because we've calculated it. Okay, so you could sort of give an eyeball estimate of what you're and how it is used in finding the angle. And what we actually want to use the angle for is to turn things towards something else, or to determine how large an angle is between the facing direction of something and another target location. Why would we want to do this? Well, if we have an artificially intelligent vehicle driving around and it needs to be following something, it needs to know how much to turn by. The next question to ask ourselves is, well, if we have an angle that tells us that is, in this case, let's say it's almost 90 degrees, we have to turn 90 degrees. Now, for us, it's intuitive that we have to turn 90 degrees in a clockwise direction to be facing the fuel. If we turn 90 degrees in this direction, then we're going to be facing over here. The tank was like that, which is completely wrong. So how do we know from that angle that the dot product has given us, which, by the way, is always positive, how do we know which way to turn, clockwise or anti-clockwise? Well, I'm going to answer that in the next video.
Is the next video the cross product? Oh, no, it's... Yeah, okay. So... Hello, Lance.
Classic reality show ending.
So I don't know how that could really be helpful in specifically in the problem that I'm having of the character movement. I guess I could say like this is the vector of what way you're pushing with your like keyboard, you know? And then like this is the vector you're currently facing. And maybe finding that angle could be nice. But it seems like if I just set the rotation equal to this vector directly, that would be like less beating around the bush kind of way. But yeah, I guess I need to. Still not quite there. Cross product it is.
Who all's here?
I just see
No
one
nerds
viewer.
here.
I think it's just
I
Lance.
see 5.
What?
I see 5.
What is going on? What up, everybody?
We were doing a chill stream.
I mean, are
We're
we?
listening to what's her name? We're listening to Penny DeBill. Penny DeBill with cross product.
Don't expect this to be too fun to watch.
I think it's educational.
Yeah, it's educational and fun.
The cross product of two vectors results in another vector. It is performed on vectors in 3 dimensions, but still has
Not to
relevancy
mention
to
she
the
has
issue we are trying to
bars.
solve, which is to determine which way to turn to face one object towards another. As you saw previously, although we are working with a two-dimensional environment, it does indeed have a third dimension that's coming out of the screen.
I saw.
Given
We're
the two
gonna link
vectors,
up
v and w,
after
the cross product
this.
is defined like this. Whoa,
After
that's
we're
a little
done,
scary,
we'll,
right?
we'll play
But
with
if-
y'all.
Yeah, we have cross product and then autopilot, and then we're done. So it should be like 30 minutes, 25 minutes. Yeah, we're just gonna wrap this bit up. And yeah, tell Sib that he could say this shit himself if he just gives us a follow. Yeah.
If you examine it closely,
Yeah, once we have 50, we can make everybody VIPs.
Yeah.
We don't get the VIP thing until that's our only goal.
Yeah, this is the one we need to like hard focus on too.
Yeah.
What?
He's right.
Ugh.
Or what should I say? He's not wrong. Maybe he's not right. But is he wrong?
My diaper. God damn it.
see why it is called a cross product, as it multiplies each component of the vectors with every other component. Let's look at it like this. The first part is v.y multiplied by w.z. This is followed by the reverse
Z.
values of v.z multiplied by w.y. Then we cross v.z with w.x, and then v.x with w.z. Then finally
What the fuck?
v.x with w.y, and v.y
What is
with
she on about right
w.x.
now? I whatever.
This cross
The resulting
product, it's
vector
hard.
is one that is perpendicular to the other two. Now the
Okay, that's
choose
what I need. I need a
There you go.
picture.
v.y and v.y with w.x. The resulting vector is one that is perpendicular to the other two. Now the interesting thing about the cross product is that it's not reversible. V cross w does not equal w cross v.
So it's a vector that is perpendicular to both of the other vectors.
Uh-huh.
How does
Uh-huh.
that make sense? So I vector this and vector. I guess I should color coordinate them. Vector that, vector that. I guess. It's kind of confusing me. Like, how is it perpendicular to both?
What do you mean? In 3D space.
Oh, so it's
Z is like perpendicular to both X and Y planes or axes, right?
yeah. So it's like it's perpendicular here, and it's perpendicular here or whatever. But really,
Yeah.
it's crossing like that. It's coming out towards you. I thought she was doing a 2D version here, but this is a two-dimensional thing. So this yellow one is the cross product, right?
Yeah.
So it's perpendicular like that in 3D space. Okay.
V. In fact, if you perform the operation the other way around, you will still get a vector that is perpendicular to both v and w, but it will be facing in the other direction. And we can exploit this fact in determining which way our tank should turn. Let's take a look at an example as to how this will work. Here is the positioning of the tank and fuel similar to the example we are working with in Unity, and these are the vectors for the forward direction and the direction towards the tank. The cross product between these yields 0, 0, negative 0.7. Now let's look at the situation when the fuel is on the other side. These are the relevant vectors, and this is the cross product. 0, 0, 0.7. In determining whether we do an anti-clockwise or a clockwise turn, the clue is in the results of the cross product. Take a close look at both of those cross products. What is the only difference?
Think hard about. Hold on. I need.
Oh, Return of the Man.
Do you see a difference?
What do you mean? There's a man on a question mark.
No, but she asked, "What is the difference between these two
Oh.
vectors?" I don't.
The
VXW. Did she add a third line in the equal sign on this one? No, wait.
What? A triple equals?
I'm just trying to find I gotta do. You know that thing where you like cross your eyes, and you could see the differences like that. I think I might need to do that.
What do you mean? There's a negative. Is that what you're looking for?
Oh, it's a negative. Okay.
It's
Did you work it out? It's the Z coordinate. In the case where we want to turn clockwise, the
This
Z
is like
coordinate
Dora.
is negative value. In the case where we want to turn anti-clockwise, the Z value is a positive value.
Good
Therefore,
lord.
from this we can deduce that if the cross product's Z value is less than 0 or negative, then we're going to do a clockwise turn. Otherwise, if it's a positive value greater than 0, then we're going to do an anti-clockwise turn.
It's the
Before we
right
connect
hand
the-
rule. Right? Or the thumb?
Yeah, it's the right hand rule. The thumb is up. The thumb is up.
So even though this is a two-dimensional game, it's you find the cross product between these two, which is a vector either coming out towards you or into the page, and that indicates which way the rotation is going.
Yeah.
Okay, okay.
Cross product in our code. Let's revisit why we're actually doing it. Okay, so this is our scene that we've currently got. Now I need the tank to be able to get on either side of this fuel tank. So I'm just going to get hold of it and I'm just going to move it across into the middle of the screen like that. So if you're following along, you might like to do that too. Now what we're going to do is program the tank when we press the spacebar to automatically turn towards the fuel. Okay, so let's go back into our code and we're going to do that in the calculate angle. So underneath your existing code, we're going to add in this.transform.rotate. And we're going to be rotating around the Z axis, which is the one coming out of the screen, so that the tank rotates around itself. And that's going to be 0 in the X, 0 in the Y, and then we're going to rotate by angle. Now remember that angle is in radians, but your transform.rotate actually wants the angle in degrees. If you leave angle like that and you press the spacebar, you'll get really tiny little rotations happening. And if that ever happens to you, just think, oh, am I in radians or am I in degrees? So also make sure that we put this in mathf.rad 2 degrees. Like that. Okay, so just save that. Now let's go back into here. What we've got now is when we press the space bar, we've basically got the tank calculating the direction that it has to face, which is what an AI character has to do. Yet we're still kind of driving it. Right, so I'm just going to not go anywhere, just press the space bar, and you can see that the tank has turned. Now, it has turned the right amount, but it's turned in the wrong direction. What happens if I go over here? So if I go over here, and I now hit the space bar, it turns through the right angle, and it's facing in the right direction. And what if I go up here? Okay, that works. And then if I go over here, that works as well. Okay, so we have this problem down in this kind of quadrant around the fuel tank. And this whole thing can be solved using the cross product as I've just shown you the calculations for. So let's go back and add that into our code. Okay, so not to confuse issues too much with all of this that's going on here, we'll actually add a new method to calculate the cross product. So it's going to return a vector 3.
And this is it's going to be a built-in thing
vectors,
here,
so vector
right? Normally.
3,
Oh, it already is.
let's
Okay.
call that V. And vector
I was afraid she was going to.
3, let's call that W.
I was afraid she was going to manually calculate the cross product. I didn't know she was going to.
She is, right?
Oh shit,
She's
she
writing
is. That's
Yeah.
the vector. Oh
Just to
god,
stay
yeah.
consistent with what we've already been learning.
I thought. Well, the thing is vector 3 dot cross, isn't it?
Yeah, I'm pretty sure that is.
So
the
that
thing.
was really
Yeah, here it
confusing.
is. Vector
I
3
thought she
cross.
was using that. I got excited.
Oh, this
And-
is the left-hand rule.
Oh no! Don't do it.
The left-hand rule.
Is he doing this kind of deal? What is he doing? What is that?
Make a right angle with your thumb and pointer, and then stick your middle.
Didn't
Your
you
middle.
teach me this?
I taught you the other one.
It was the same
Right
thing, just with your
hand.
other hand.
Right-hand rule is when your thumb is up.
Oh. And then this is creating like an axis with your fingers. Why do
There's
I?
two different ways to do it.
No, man, no.
I'm shocked.
So wait, what is
I
your
never
method?
considered.
I thought your method was just.
My
like-
method is it's the gun way, but then you stick your middle finger across from your other two.
Oh, okay.
This is what is this?
Well, it's the
mode?
same thing. It's just flipped.
Is it?
Right? I mean, I'm doing it with
I'm
both
just
hands.
holding my hands up too. Yeah.
Because you do the finger guns and then you
Can
point
you
your.
make a cube out of this?
Whoa.
I think you can.
There's probably a way. I think that's it right there.
I had no idea I had two axes at the same time that I could manipulate with my fingers.
Carry on.
Then what we need to do is find the difference of the multiplication of
Switch
all
the
of the
windows.
cross
Yeah, good.
vectors.
I got it.
Okay,
yeah.
so let's do them
Yeah,
one by
I
one.
remember
We'll do,
this
first
time.
of all, float.
Should we, do you want to just skip to when she does the built-in? Like, we're never gonna write out the
Yeah.
cross product manually. I don't know.
Mult. Y mult. And a new vector. And then a little multiplier of 1 or minus. Put if the which will make it negative or positive down
Okay,
here.
well now she's just using
Clockwise or
this
anti-clockwise for our angle, which will
as the same way we
So
would
the
use
Z
that
value
built-in.
is less than 0. Then we're actually going to put clockwise equals -1, like that. So it will turn us clockwise or anti-clockwise for our angle, which will make it negative or positive down here.
Wait, okay, if so, this is just checking is the cross product positive or negative, and then if it's negative, set clockwise to -1. If it's positive, clockwise should be 1.
When we
Okay.
multiply by that clockwise value. So multiply clockwise just like that.
Okay.
All right, so that's all you have to do. Let's test this out. Save it. Go back into Unity. Press play. Now, we know that this bottom corner down here is the one that was causing all of our heartache before. So hitting the space bar, I'm now facing in the right direction. And now facing the right direction. And we can go over and check all of our quadrants around this. And, yep, and then go up here. And that's right. And then over here. And that's right.
I hope
as
it's
well.
not 2D the
Okay,
whole
great.
time.
So
I
that
guess
is
it
how
probably
the cross product
won't
helps
be,
you
but-
to know which direction that you need to
I guess it
take,
probably
or at least
won't
not you,
matter.
because you know it's the AI that you develop. Okay, so how can we do this in Unity without all of this cross stuff?
Yeah, I was
well,
watching
Unity
that,
has this really great method
that
that we haven't
Bigfoot
used yet,
game that
which
came
is
out,
not
like,
just an angle,
last
but
year.
it's called, and if we put it down in
And I
here,
remember there was
let's
a
put
thing where
float
the
Unity
pathfinding
angle,
couldn't
and we'll
deal
make it
with
equal vector 3
couldn't
dot,
deal with
and
hills
we want
very
angle
well.
between angle
I don't remember there
sine.
being a
So the sine
Bigfoot
one
game.
is going
I
to
think
give
it's
us a
called
negative
Find
or a
Bigfoot.
positive. And we're going to give it TF and FD, and it also needs to know the axis that you're rotating around. And we're rotating, in this case, around this dot transform dot forward. Remember, our axes
that was
the
an
X and Z
Unreal
flipped
game.
in the case of this 2D vehicle. Okay, so that will give us our Unity angle, and then what we can do is get rid of this clockwise that we put in there before, change this to Unity angle, like that. And let me just check that we're returning a radian. So sine angle returns it in degrees. Okay, so we don't actually need that multiplication there. Always good to check. Okay, so we'll save that and go back here into Unity and press play and test out our very starting position. Yep, works very nicely. Over here, turn, yes. Go up here and turn, that works. And then over here, and I have a suspicion that, yep, it's going to work as well.
A little
Okay, so that's the
overconfident
cross
there.
product, the power of the cross product in this particular situation, which is used in AI, and also how you do it in Unity, which is...
She should act really
great.
scared and unsure if it's going to work the whole time, so that we have like
Like us.
like a shared experience with her. That one was helpful. That was definitely helpful in like conceptualizing the difference between the two. So dot product is the measure of, I guess, how close it is to a 90-degree difference between the two angles.
Yeah, just measures the angle between them.
And then dot product or cross product is figuring out which direction it's rotating in. I guess that's specifically in games, though. I don't know if that's
Cross product is just the perpendicular vector to
yeah.
both.
That's the more general.
But I think cross product is especially helpful in this case.
Yeah.
'Cause we always do that thing where it's like we have forward, up, and right are like the vector 3 built-ins that I feel like I've used the most.
Yeah. Okay, so this is the last one. This one, I think this one it's like a challenge. She says students will be challenged to build an autopilot system. I guess we're about to watch it, so we'll find out.
In this video, we're going to start with some AI code that will autopilot our tank. But before I show you how to do it, I'd like you to put into practice the skills
Oh,
you've
wait.
learned so far with moving.
I don't think this is
3D
the right
characters.
video.
Did I skip one?
My video is different than yours.
Let me go back to cross product. Just continue to next item. Yeah, autopilot. You see on the left right here the order that it goes in. What are you on?
Look at my screen. Mine says Pikmin 2 Louis AMV.
Wish I could find a way to disappear. All these thoughts, they make no sense. I found this in ignorance. Nothing seems to go away over and over again. Just like before. Everything you say to me. One step closer to the edge, and I'm about to break. I need a little room to breathe. One step closer to the edge, I'm about to break. Everything you say to me. One step closer to the edge, and I'm about to break. I need a little room to breathe. One step closer to the edge, and I'm about to break. Shut up when I'm talking to you. Shut up when I'm talking to you. Everything you say to me. One step closer to the edge, and I'm about to break. I need a little room to breathe. One step closer to the edge, I'm about to break. Everything you say to me. One step closer to the edge, and I'm about to break. I need a little room to breathe. One step closer to the edge, and I'm about to.
Well, what did you learn from that one?
Okay, I think you're right that that wasn't the same video. I think those were different videos.
Oh,
I'm not sure.
you
I
got
don't-
me. I think
we might
up
need to
to me.
roll that one back. I'm not sure if I really got that one. Was that at 2x speed?
No. I think that was 1 times. Only 480p.
Maybe that's why it didn't really sink in for me.
Mm.
Okay, well, I mean, should we watch my version of it then, or
I guess let's see the difference, maybe.
okay?
Oh yeah.
In this video, we're going to start with some AI
She
code
loud.
that will autopilot our tank. But before I show you how to do it, I'd like you to put into practice the skills you've learnt so far with moving the 3D characters using vectors and what we've done with these angles and the tank to get your project to a stage like this. Let me press play. So what I've done inside of the drive script is I've created a autopilot. Now it's only very simple at the moment, and what I'd like you to do is actually replicate this if you can. So when you hit the T key it's going to look at the fuel tank, so it snaps around at the angle to look at the fuel tank, and then it's going to continue on its way to the fuel tank. Now you can see at the moment it's not
Whoa.
quite behaving as it should. The debug lines there are giving us some really nice patterns. When you press T again, it turns off the autopilot and you can drive around again. So if I drive back over to here, and if I hit T, it's going to flip around, look at the fuel tank, and then also move towards the fuel tank. Now you can see there it's constantly correcting the angle. Let me hit T again for you. That's okay. If you get to that point where it's jittering and constantly correcting the angle, that's fine. Okay, so give that a go. Pause the video while you try and put that into practice. Most of the code is already in the tank's drive script, and you'll just have to add that little bit extra that automatically pushes the tank forward, as well as including the T key that will turn that autopilot on and off. And when we come back, I'll show you what I've implemented so far.
So, I mean, do we want to give that a go, or should we just let it go, you think? Because, I mean, then we have to download her project file.
Yeah, I don't think we should do it. But maybe try and figure out what it is that she wants
Okay.
us to do.
Well, there's no lerping at all. It just snaps immediately to everything. So I'd imagine it's just like you set up the T input thing. Like you set up the fact that
Yeah.
T is an input. That whatever. Use T as a button, and then it says on when T gets pressed. Maybe that like unlocks something in the update. Maybe there's an if statement in the update that's like moves you along the vector, you know, and does the angle,
Yeah.
and then hitting T on like flips a boolean or something that opens up that like gate in the update, and then that update just moves along the vector and is constantly correcting that angle, because those are both in update for sure. It's just a matter of like maybe it's just a method that's in update and then there's an if in that method or something, but I think T is just a boolean that flips on and off that unlocks or locks some method within update, and then that method is just the same code that she had before. So let me get that up. Actually, has she even shown that in this video? No, she hasn't. I don't remember exactly what the video was, but it was like transform move to or something like that, and then also transform look at. Both of those are within update, with the angle being the dot product times the cross product, and the distance being a vector that is just calculated as the distance between the two. And then once you reach it, I guess actually she didn't even set it up in that way, because she still had to hit T to turn it off even when she was already at her destination. So it doesn't even do that. It's just the same thing as the beginning of the video where the AI went to that dot and was just like teleporting around it.
Yeah. I mean, yeah, I mean, it's really just implementing the two modes. And the first one she basically set up like really early on.
Yeah. Well, let's just see what she says.
While you try and put that into practice, most of the code is already in the tank's drive script, and you'll just have to add that little bit extra that automatically pushes the tank forward, as well as including the T key that will turn that autopilot on and off. And when we come back, I'll show you what I've implemented so far. So how did you go with that? Let's have a look at my code. Okay, so, well, we might as well start with calculate angle because I've already got it here on the screen. The calculate angle is the same as you've already written, but I have gone back and just used our angle that we're calculating up here. Probably just because there's a little bit more control over it because we're using the base math functions. If you've left it with Unity's calculate angle, then that's fine. And I've also left the debugs in there just so I can see that we've got the correct values. And in this case, I've also made sure that inside of my rotate, I'm rotating by degrees and not radians, because remember, the angle that we calculate using the base mathematical trigonometry functions will return a radian, and we actually want to rotate with degrees. Okay, so the calculate angle is going to stay there. Now, just a little bit further down, I've written a script called autopilot. Now, just before it, I have declared a variable called auto speed that we're going to use for the speed. And you could define this up the top of your code, but I've got it down here so that we can actually see it all together. Autopilot, what it does is it calculates the angle, because remember that calculate angle was turning the tank at the same time, so we can just reuse it. And then all we need to do is push the tank forward. So we use a translate for the tank's dot up multiplied by the auto speed. Now, the tank's transform dot up is its y vector, which is the direction that's actually facing and moving in. Okay, so not the forward vector as it would be in the 3D environment. Now, if you remember back when we were moving our little 3D characters along our vectors, we were normalizing them to make sure we had a vector that was length 1. And before, I mentioned that these vectors, transform dot up and transform dot forward, are already of length 1, so we don't need to normalize them. So then we're just multiplying by speed, and we're making sure that we do it in world space, because that's how we've calculated the angle, basically. Okay, and then how do we run this? Well, if we go down to the bottom of our code, you can see underneath the spacebar that we've got an if get key down is the T key, then autopilot, which is a Boolean value declared up the top. Better just go up there and show you. Here it is here. Okay, it's initially set to false, and then back down in our update, autopilot is going to be set to not autopilot. And this code basically switches it between true and false each time you hit the T key. Then underneath that, if we're in autopilot, then we want to run autopilot mode. So how did you go with that? Let's just go back and have another little look at what we're getting here. So if I press play and hit the T key, it flips around immediately and makes its way towards the fuel tank. Now, it is jittering. Why is it jittering? Because there is just a slight little error. Or I shouldn't say error, but maybe it's more of a rounding off error when the calculations for the angle are done. And because they're being done all of the time, each movement of the tank is going to just give you a slightly small error in the angle, and therefore it just keeps correcting itself each time, which doesn't look that good really. So we need to go ahead and fix that. But we're not just going to fix it immediately. What we're going to do instead is have the tank move more naturally. So if the tank, let's say, is down here, facing that way, if we went into autopilot mode, for an actual game character, you're not going to expect that it just snaps around like that. What you'd rather it do, and I'm moving this with the arrow keys at the moment because we've still got that drive code in there, the autopilot should probably start turning, like that until it goes towards the tank. Okay, so we're going to now modify our code. So instead of snapping around to that angle, is that we turn naturally like that. How do you think you might do that rather than taking the entire angle in one go?
That's kind of different though, because she's like moving around and then going. Like it doesn't just rotate around that axis. It's like moving as well as rotating. It's like I actually don't really know how you would do that unless she just can't rotate.
She might just be. I think maybe she'll write a way to make it go in a circle.
And then like have it come off of that circle towards the thing or something?
Yeah.
Okay. Unless she just can't rotate independent of the movement. Can she do that? I don't know, whatever, we'll see.
Oh. Well, it's actually quite simple. We go back into our drive script and we go up to where the angle is calculated, which is up here, and it's also applied in here. We can actually put in a divider. So rather than the entire angle being applied in one go, we can divide it, or in this case I'm just going to multiply it by a fraction. So if we put 0.5f, so rather than the whole angle being applied, we'll apply half of the angle each time. Just save that. Now let's go back and have a look at the effect of doing that. So if we press play and we hit the T key, did you see how it turned a little more smoothly? It's probably too fast. Let's go back and have another go. Let's change this down to 0.02. Let's try that. So save that, and we'll go back.
Yeah, it doesn't seem like she's doing it as smart as she acted it out to be.
And
oh,
now
never mind.
Smoothly turns around towards the tank. Now there's a slight little bit of jittering going in there, but not as much as before. So what is the tank actually doing? Well, instead of applying the whole angle, it's applying 0.02 of the angle each update. So that means it just takes a little percentage turn each time. So it's just going around like that, whilst at the same time it's moving forward, which is a much more naturalistic looking movement for us. Let's have another look. Now, because the angle is calculated each update, the angle that we need to turn through is getting smaller and smaller each time. So we're taking an even smaller step of that angle as we're moving towards it. Now, you might have even gone as far as stopping the tank when it gets to the destination point so that it's not doing that little dance around here when it's meant to just stop because it's reached its destination. So let's go ahead and put that code in to fix that problem.
So Why is it moving at kind of like an arc though? Like, why isn't it moving in a straight line to the thing still?
Because it's moving forward.
Oh, the tank actually. I guess I assumed it was just kind of independent of rotation. But no, yeah, that makes sense actually. Okay.
Yeah. It starts moving forward.
Okay, so we go back into drive. Now we need to know what the distance is in order to continue autopiloting. And if it's within a certain range, then we want to stop the autopilot from working. So going back up to our calculate distance, which we've already done here, we might as well use it. But instead, I'm just going to make this into a float return. And then let's just return the distance that we've calculated here. Then we can use that down in our update. So coming down to update, we're going to just add a few extra little brackets around here. And then before we do an autopilot, we'll go if calculate distance is greater than 5, then we will continue to autopilot. Otherwise, we can consider ourselves at our destination. Right, so let's save that, flip back into Unity and press play. And now when we hit the T key, we're going to turn towards the fuel. And then when we get there, we're within a certain range, we will actually stop. Okay, so turn off the autopilot and we can then drive it again and we can test it from down here. So hit the autopilot and it will come back and go towards the fuel. Now, while the autopilot is still turned on, if we get hold of our fuel over here in the scene and move it around, you'll find that our tank will just follow it around. So if you were to put some drive script onto the tank and turned off that arrow key driving for the tank and put it on the fuel instead, you'll be able to have a tank that's going to follow something else around, another target object. All right, so there we go. We've now applied a very nice little autopilot script to a game character, which is the tank in this case, and that is essentially a very basic AI program that you can put on characters that you want to follow other objects in your scene.
Okay. Well, that's the end of that little chunk. So I think we're probably done for today. But I would like to say maybe off stream we should oh wait.
Did what?